Hello students, this is Shachi. Welcome to my channel Crack Chemistry. Today I am going to explain a class 12 topic. The name of the topic is Reactions of Aldehydes and Ketones due to alpha hydrogen atom. In this topic we will learn Aldol Condensation. Students, this topic is included in the chapter Aldehydes, Ketones and Carboxylic Acids. In today's session, I'll tell you a very interesting trick with the help of which you can never commit a mistake for writing products of aldol condensation. Students, before starting, I want to remind you to subscribe my channel for getting information about further important uploads, and press the like button if you like this video and share this video with your friends. So now come with me and let's crack chemistry. So our topic is reactions of aldehydes and ketones due to alpha hydrogen atom. We will start our discussion with acidity of alpha hydrogens of aldehydes and ketones. Students, alpha hydrogens of aldehydes and ketones is acidic in nature. So first of all, I want to discuss with you what is an alpha hydrogen atom. Students, alpha hydrogen atom is that hydrogen atom which is attached to alpha carbon atom. Now you must be thinking, what is alpha carbon atom? Alpha carbon atom is that carbon atom which is attached next to the functional group. Students, in aldehydes and ketones, functional group is carbonyl group. So this is carbonyl group. The carbon atom which is attached next to this carbonyl group is called as alpha carbon atom. So you can see here, this is the alpha carbon atom. Now the hydrogen which is attached to alpha carbon atom is called as alpha hydrogen atom. So you can see here, this hydrogen atom is alpha hydrogen atom. And this alpha hydrogen atom is acidic in nature. So we will see why this alpha hydrogen atom is acidic in nature. Students, this alpha hydrogen atom is acidic in nature because of the presence of a strong electron withdrawing carbonyl group. So because of the presence of a strong electron withdrawing carbonyl group, the loss of alpha hydrogen atom is favored on the approach of a base. So this B represents a base. So when a base approaches a carbonyl compound, it will abstract alpha hydrogen atom. Alpha hydrogen atom is lost because of the strong electron withdrawing effect of carbonyl group. In class 11th, you have learned the Lowry-Bronsted concepts of acid and bases, where you have learned that whenever any acid loses a proton, a conjugate base is formed. So you can see here, whenever a carbonyl compound loses a proton, it results in the formation of a conjugate base. So the conjugate base is written here. Once a conjugate base is formed after the loss of alpha hydrogen atom from a carbonyl compound, this conjugate base is further stabilized by resonance. You can see here, this is the carbonyl group, and the oxygen atom of the carbonyl group is more electronegative. Therefore, electron pair of the C double bond O bond will be shifted towards oxygen atom, as a result of which the lone pair of electrons on alpha carbon atom will be shifted between carbon and carbon. You can understand that resonance stabilization is taking place here. So the resonating structure will be CO minus, double bond C. These are the resonating structures of conjugate base. So now we can conclude that alpha hydrogen atom of carbonyl compounds are acidic in nature. They are acidic in nature because of the strong electron withdrawing effect of carbonyl group, which favors the loss of hydrogen as a proton on the approach of a base, resulting in the formation of a conjugate base. And once a conjugate base is formed, it is further stabilized by resonance. I hope it is clear to you. So whatever points I have explained to you just now are written here in this slide for your convenience. Now we will learn aldol condensation. Students, aldol condensation is based upon acidic nature of alpha hydrogen atoms. So first of all, we will see what is aldol condensation. Students, aldol condensation is shown by only those aldehydes and ketones which contain at least one alpha hydrogen atom. So when such aldehydes which contain at least one alpha hydrogen atom are treated with a dilute alkali like NaOH or BaOH taken twice, etc., this dilute alkali acts as a catalyst. So aldehydes having at least one alpha hydrogen atom on treatment with dilute alkali, they undergo a condensation reaction and results in the formation of a condensation products. Children, aldehydes form beta hydroxyaldehydes which are called as aldol, and the ketones form beta hydroxyketones which are called as ketone. Now we will learn aldol condensation by taking few examples here. First of all, we will see whether methanol shows aldol condensation reaction or not. Children, methanol has the formula SCHO. So I told you in the beginning that what is the essential condition for a carbonyl compound to show aldol condensation. The essential condition for an aldehyde or ketone to show aldol condensation is that it must possess at least one alpha hydrogen atom. So we will check whether methanol contains an alpha hydrogen atom or not. So what is alpha hydrogen atom? I told you in the beginning, alpha hydrogen atom is that hydrogen atom which is attached to alpha carbon atom. So what is alpha carbon atom? Alpha carbon atom is that carbon atom which is attached next to the functional group. So you can see here in the case of methanol, the functional group is CHO group. And if you look carefully, you can find that functional group is attached to no other carbon atom. It means methanol doesn't have any alpha carbon atom. If methanol doesn't have any alpha hydrogen atom, there is no question of having alpha hydrogen atom. So now you can conclude that as methanol doesn't have any alpha hydrogen atom, it will not undergo aldol condensation reaction. Now we will consider the second example of benzaldehyde. Students, the formula of benzaldehyde is C6H5CHO. So you can see here that it consists of a benzene ring having a CHO group. So now again we will check whether benzaldehyde undergo aldol condensation reaction or not. So for that we have to check whether it has alpha hydrogen atom or not. So you can see here CHO is the functional group and the carbon atom which is attached to functional group is called as alpha carbon atom. So this is the alpha carbon atom. But you can see that benzaldehyde has alpha carbon atom but no alpha hydrogen atom because no other hydrogen atom is attached to alpha carbon atom. It means benzaldehyde doesn't have any alpha hydrogen atom. So benzaldehyde will also not undergo aldol condensation reaction. So this is a conclusion, as formaldehyde has no alpha carbon atom. So no alpha carbon atom means no alpha hydrogen atom. And benzaldehyde has alpha carbon atom but no alpha hydrogen atom. Therefore, both benzaldehyde and formaldehyde will not undergo aldol condensation reaction. Now we will consider the case of ethanol. Formula of ethanol is CH3CHO. Its common name is acetaldehyde. Whether ethanol will undergo aldol condensation or not, again we will check as we have checked previously. So this CHO is the functional group. Now you can see that the carbon atom which is attached to functional group is called as alpha carbon atom. This is the alpha carbon atom and 3 hydrogen atoms are attached to alpha carbon atom. It means acetaldehyde has 3 alpha hydrogen atoms. So it means acetaldehyde or ethanol will undergo aldol condensation. Now I am going to tell you a very interesting trick with the help of which you can never commit a mistake while writing aldol condensation reaction. Children, always remember, in aldol condensation 2 molecules will take part in the reaction. First molecule of ethanol I have written as it is, but the second molecule I am writing like HCH2CHO. Means instead of writing CH3, I am writing H separately. So you can see here, this is the alpha hydrogen atom of second acetaldehyde molecule. You can see that the reaction is taking place in the presence of dilute NaOH. So how the reaction will take place? Alpha hydrogen atom of second ethanol molecule will attach itself to the carbonyl oxygen of the first ethanol molecule. Now rest of the atoms we will write as it is. So you can see here the product formed is CH3, then CH, and on the carbonyl oxygen atom H was attached, so product is CH3, CHOH. Rest of the atoms I am writing as it is. CH3, CHOH, CH2, CHO. The name of the compound will be 3-hydroxybutanol. On further heating, converts into alpha beta unsaturated aldehyde. So you might be thinking, what is alpha beta unsaturated aldehyde? Alpha beta unsaturated aldehyde is that aldehyde which consists of unsaturation. Unsaturation means double bond between alpha and beta carbon atoms. So you can see CHO is the functional group. The carbon atom which is attached to CHO is called as alpha carbon atom, and the carbon atom which is present next to alpha carbon atom is called as beta carbon atom. So you can see here, unsaturation means double bond is present between alpha and beta carbon atom. So this is an alpha beta unsaturated aldehyde. So 3-hydroxybutanol on heating results in the elimination of water molecule. So from where water molecule is lost? OH of the beta carbon atom and H of the alpha hydrogen atom combine and form one water molecule, and they are eliminated. So your product will be butanol. I hope it is clear to you. So if you have understood this trick, you will never commit a mistake while writing Aldol condensation reaction. Now we will consider about propanone. Children, common name of propanone is acetone, which is having the formula CH3 COCH3. So we will check whether acetone will undergo Aldol condensation or not. So for that we have to check whether it has alpha hydrogen atom or not. Children, this is the functional group. You can see here C double bond O. This carbonyl group is the functional group. So we have to see whether any carbon atom is attached to this functional group or not. You can see that on both sides of the functional group we have 2 carbon atoms. It means this compound has 2 alpha carbon atoms. Now the hydrogen atoms which are attached to alpha carbon atom are called as alpha hydrogen atoms. So you can see that acetone has 2 alpha carbon atoms. One is this alpha carbon atom which I have written on the downside, and one is this alpha carbon atom which I have written on the left hand side, and on each alpha carbon atom there are total 3 hydrogen atoms are present. So acetone in total consists of 2 alpha carbon atoms and 6 alpha hydrogen atoms. It means acetone will definitely undergo Aldol condensation reaction on treatment with a dilute alkali like NaOH or BaOH taken twice, etc. Now another important point which you must remember, that in Aldol condensation always alpha hydrogen atom of the second molecule will take part in the reaction. So this is the alpha hydrogen atom of the second acetone molecule which I have underlined here. So when 2 acetone molecules they combine together in the presence of barium hydroxide, they will react like this. You can see here, alpha hydrogen atom of second acetone molecule will attach itself to the carbonyl oxygen atom, and rest of the groups and atoms I'll write as it is. So first I'll write this CH3, CH3, then single bond C, but double bond O is converted into OH. Then CH3 will be written as it is. Then we have CH2, C double bond O, CH3. So the name of the compound will be 4-hydroxy 4-methyl pentane 2-on because the second carbon atom has a ketonic group. Now this compound on further heating will convert into an alpha beta unsaturated compound. So for formation of alpha beta unsaturated compound, always remember that from beta carbon atom, this is the functional group. So this carbon atom is alpha carbon atom. Next to alpha carbon atom we have beta carbon atom. From beta carbon atom OH is lost, and from the alpha carbon atom one hydrogen is lost. They form H2O molecule. So the resulting product will be CH3, single bond C, CH3, double bond CH, single bond C, double bond O, CH3. The name of the compound will be 4-methyl pent 3-ene 2-on. I hope it is clear to you. So after learning aldol condensation, we will discuss cross aldol condensation. Cross aldol condensation is the aldol condensation reaction between two different aldehydes, or between two different ketones, or between aldehydes and ketones. And one more interesting point, if both of the reactants contain alpha hydrogen atoms, a mixture of 4 products are obtained. But if only one of the reactant contains alpha hydrogen atom, then one major product will be formed. We will consider the aldol reaction of a mixture of ethanol and propanol. So first we will see whether ethanol and propanol they contain alpha hydrogen atom or not. So in the previous slides we have discussed that ethanol contains an alpha hydrogen atom. In fact, ethanol consists of 3 alpha hydrogen atoms. So this is ethanol, and ethanol consists of 3 alpha hydrogen atoms which are written here. These are the 3 alpha hydrogen atoms. Now look at the propanol. This is the functional group CHO of propanol, and this is the alpha carbon atom. On the alpha carbon atom you can see that it consists of 2 alpha hydrogen atoms because alpha carbon atom contains 2 hydrogen atoms. So propanol. So propanol consists of 2 alpha hydrogen atoms. So as both the reactants contain alpha hydrogen atom, we will get a mixture of 4 different products. So we will consider one by one. So first of all we will see when a mixture of ethanol and propanol are treated in the presence of any dilute alkali like NaOH or BaOH taken twice, etc. They react together, they undergo aldol condensation reaction, and 4 different products are formed. So how these 4 different products are formed, I am going to show you in very detail. First product you will get by the reaction between 2 molecules of ethanol. So when 2 molecules of ethanol react together, we get this product. And similarly, when 2 molecules of propanol they react together, you will get this compound. Similarly, when ethanol reacts with propanol, then we will get these 2 products. So when 2 molecules of ethanol react together, you will get a self-aldol product. Similarly, when 2 molecules of propanol they react together, you will get a self-aldol product. But when 1 molecule of ethanol and 1 molecule of propanol they undergo aldol condensation, you will get a cross-aldol product. We will see the formation of 4 different products by the reaction between a mixture of ethanol and propanol. So first we will consider the reaction between ethanol and ethanol. So this is the first molecule of ethanol, and the second molecule, as I have told you, we will write in such a way that alpha hydrogen atom is clearly shown here. So I am writing second molecule of ethanol in this way, HCH2CHO. Then on reaction with dilute alkali, it may be dilute NaOH, it may be dilute barium hydroxide, what will happen? Alpha hydrogen atom of second ethanol molecule will attach itself to the carbonyl oxygen of the first ethanol molecule. So your product will be CH3, single bond CH, OH, CH2, CHO. So the name of the product is 3-hydroxybutanol. And this 3-hydroxybutanol on further heating will lose a molecule of water and will result in the formation of an alpha-beta unsaturated product. How the loss of water molecule will take place? I told you that OH group will be lost from beta carbon atom and H will be lost from alpha carbon atom. So one OH from here, H from here, your product will be CH3, single bond CH, double bond CH, CHO. So the name of the product you can see here is butanol. It is an alpha beta unsaturated aldehyde. The product's name is butanol. I hope it is clear to you. Now we will write the reaction between two molecules of propanol. So propanol's formula is CH3CH2CHO. And the second molecule of propanol I'll write in such a way that alpha hydrogen atom is clearly visible. So second molecule you can see here I have written like CH3CH2CHO. These two molecules on treatment with dilute NaOH undergo Aldol condensation. Alpha hydrogen atom of second propanol molecule attaches itself to the carbonyl oxygen of first propanol molecule and results in the formation of Aldol condensation product, which we can directly write by looking at the reactants as CH3, CH2, CHOH, CH, CH3CHO. So this is your Aldol condensation product. The name of the compound will be 3-hydroxy-2-methylpentanol. So this 3-hydroxy-2-methylpentanol on further heating results in the loss of a water molecule. So your product will be CH3, single bond CH2, single bond CH, double bond C, CH3, CHO. So the name of the compound will be 2-methylpent-2-enol. So we have formed the second product which was formed between two molecules of propanol. So this was also a result of self-Aldol condensation. Now we will see the cross-Aldol products which are formed by the reaction between a molecule of ethanol and propanol. So in the first case I am writing ethanol first. So ethanol is CH3, single bond C, single bond H, double bond O. And the second will be propanol. So propanol I will write exactly in the same way as I have written in the previous case. I have to show the beta hydrogen atom clearly. So I am writing H, CH, CH3, CH2, CHO. So on reaction with the dilute alkali like dilute NaOH, beta hydrogen atom of second molecule which is propanol here attaches itself to the carbonyl oxygen of the first reactant. So your product will be CH3, CHOH, CH, CH3CHO. So the name of the product is 3-hydroxy-2-methylbutanol. So this 3-hydroxy-2-methylbutanol on further heating results in the formation of an alpha-beta unsaturated aldehyde by the loss of water molecule. So your product will be CH3, single bond CH. OH will be lost from here and H will be lost from the second molecule. So a double bond will be developed. CH3, CHO. So you can see that this is also an alpha beta unsaturated aldehyde the name of the product will be 2-methyl-butene-ol. I hope it is clear to you. So the product which is formed here is cross-aldol product. Now for writing the fourth product by the reaction between ethanol and propanol, we will write propanol first and ethanol as a second molecule. So CH3CHO I'll write in such a way that its alpha hydrogen atom is clearly visible. On reaction with dilute alkali, alpha hydrogen atom of ethanol attaches itself to the carbonyl oxygen of propanol. So the product will be CH3, CH2, CHOH, CH2, CHO. So this product is also called as cross-aldol product because this is formed by the reaction between two different aldehydes. The name of the product will be 3-hydroxypentanol. So 3-hydroxypentanol on further heating results in the formation of alpha-beta unsaturated aldehyde. Product's name will be pent-2-enol. I hope it is clear to you. So here I can show you the four different products which are formed by the reaction between two different aldehydes. One was ethanol and other was the propanol. So we have discussed in very detail that but-2-enol is formed by the reaction between two molecules of ethanol, and 2-methyl-pent-2-enol is formed by the reaction between two molecules of propanol. As these two products are formed by the reaction between two similar aldehydes, so they are the simple or self-aldol products. Then here these two molecules, they are formed by the reaction between one molecule of ethanol and one molecule of propanol. So you can see here one of the product when we have written ethanol first is 2-methyl-but-2-enol, and the other product when we have written propanol first is pent-2-enol. So these two products are called as cross-aldol products because they are formed by the reaction between two different aldehydes. So you can see here all these products I have explained you in very detail how these products were formed. So first product is but-2-enol. Second product is 2-methyl-pent-2-enol. Third is 2-methyl-but-2-enol. And the fourth product is pent-2-enol. I hope it is clear to you. Now one more important point. Ketones can also be used as one component in the cross-aldol condensation. First reactant is benzaldehyde, which doesn't have any alpha hydrogen atom, and the second reactant is acetophenone, which consists of alpha hydrogen atom. So this is acetophenone C6H5COCS3. Where is alpha hydrogen atom? This is the functional group. You can see here this is the functional group, and the carbon atom which is attached to functional group is called as alpha carbon atom, and the hydrogens which are attached to alpha carbon atom are called as alpha hydrogen atoms. This acetophenone contains 3 alpha hydrogen atoms. Next side also you have one alpha carbon atom, but this alpha carbon atom doesn't contain any alpha hydrogen atom. So you have to write the reaction in such a way that one of these 3 alpha hydrogen atom will attach itself to the carbonyl oxygen of the first molecule, which will be benzaldehyde. So we have written the product here. This is the C6H5 benzene ring, then CH, and the carbonyl group of benzaldehyde, one of the alpha hydrogen atom of the second molecule, which is acetophenone, gets attached, resulting in the formation of a condensation product, which is C6H5CHOH. Then CH2 we are writing from this side, C double bond O C6H5. So you can see the name of the product is 3-hydroxy 1,3-diphenyl propane 1-one. And this condensation product on further heating will result in the formation of alpha beta unsaturated product. So your product will be C6H5 CH double bond CH single bond C double bond O C6H5. So the name of the compound is 1,3-diphenyl Propanone. Children, thank you so much for watching this video. I hope each and every point is clear to you. In case of any doubt, please post your doubts in comment box. Press the like button if you like this video, and don't forget to subscribe my channel and share this video with your friends. Thank you so much. Have a nice day.